This video will demonstrate how to use the rules to define a Lewis structure for a given molecule, and then use VSEPR theory to actually pull information out of that Lewis structure. And so this one we'll be doing xenon tetrafluoride, XEF4. The first step is to count up the valence electrons. So from xenon we'll pick up 8. Each fluorine will give us 7, so that's 4 times 7. And 28 plus 8 gives us a total of 36 electrons to work with. So in the second step we want to write out the basic structure, placing xenon in the middle, and we'll have 4 fluorines attached to it. This step uses up 8 electrons, which brings us down to 28 left to work with. In assigning octets, when I do the octets around the outside, I'll have 6 electrons to put on each fluorine. And so 6 times 4 gives me 24. So I'll be using up 24 electrons in this step, leaving me with 4. So the first step then is to assign all of these. And it should be straightforward to recognize that this leaves me with xenon already having 8. So its octet is fulfilled. However, xenon is capable of using expanded octets through DSP type hybridization. So I can put the last 4 on the xenon, leaving me with 0. So everyone has an octet. We have something that has an expanded octet, and that's all okay. So the Lewis structure portion is done. And now I want to count up the groups of electrons around my central atom. I have 1, 2, 3, 4 picked up from the bonds, and 5 and 6 are my 2 non-bonding pairs. So because I have a count of 6, my hybridization then is going to be D2sp3. The electronic shape comes directly from the hybridization, and that is octahedral. The molecular shape is a result of having octahedral electronic shape with 2 non-bonding pairs, here and here. And so my molecular shape then is square planar. Now the dipole moment results from the fact that I have a strong electronegativity favoring the fluorine as the negative end of the dipole. But these individual bonds all lie in a plane, and they're separated by angles of 90 degrees, so there is no overall dipole. So on the dipole question we have no. The only thing left to do now is determine a formal charge. So the formal charge requires that I look at the xenon and one of the fluorines, because they all have the same bonding structure here. A single bond with 6 electrons that are non-bonding. So formal charge requires me to take into account the valence electrons, what our situation was before the molecule, and compare that to the situation after. So there are 2 pieces of information I need. That's the number of non-bonding electrons, in this case 4, and in this case 6, and the number we can expect to get from the shared electrons. 2, 4, 6, 8. Assuming a 50-50 split, we have 4 here and 1 here. And in this case, everything has 0 for a formal charge. If we add up all of those zeros, we get an overall neutral formal charge. And that neutral formal charge matches up nicely with the neutral molecular charge. When those 2 charges are in balance, that means that we're probably doing this right, in addition to, of course, all of the other information. And so this is a proper Lewis structure then for XEF4, xenon tetrafluoride.